Hi, my name is Maximiliano Firtman, and I'm a mobile web developer. I've been doing websites and web apps for 25 years, and mobile apps for 20 years. I created this course to answer the question of what happens when your user is closing your progressive web app, your browser, or is leaving your app in the background. What happens with your JavaScript code? In this course, we're going to understand how to detect when your app goes to the background, how to wake up your code even if your app is closed by using different APIs, including web push notifications. I hope you enjoy this course. How many of you on iOS or Android, are actually doing this many times per day? Like closing your app, swiping up or swiping right. So I have here a couple of yeses, and a couple of no's. And for those of you saying yes, why are you doing that?
People say that it helps battery life, but it doesn't actually.
It saves battery life. Yeah, there are a lot of people thinking that it will save battery life. And it's not true. It's exactly the opposite. And that has to do with the life cycle of a mobile operating system with their apps. And our web apps are actually within that life cycle. They can be a tab in the browser, or they can be a standalone PWA. It doesn't matter. It's actually the same. We are actually within that OS. So let's try to understand how that works. So going back here, on a desktop operating system, it can be Linux, Windows, Mac OS, Chrome OS. Typically, when you are inside one app, so that's the orange one, that's your app that is running, but you may have other, so that's the active app. The orange one is the active app. So you may have other apps that are also running, and they're all running, even if they are in the background or minimized or hidden somehow. If you press Alt-Tab, you change your active app, but your previous app is still running. It's in the background but running. That's a desktop operating system in general. When mobile appeared, we as users, we thought that that was the case also for mobile. And that's why a lot of people are actually closing apps, because they think that they are consuming resources. But that's not how they typically work. On mobile operating systems, this is a general idea. There are some exceptions, but in general, you have one app that is running, the active app, and the other apps that you see in the multitask manager are paused or suspended. Different names to this. So they're not executing code. And what you see in that multitask manager is just screenshots of that app, not really like the current UI for the app. It's a screenshot. If you change your app, now you have another app that is active, and your previous app goes to suspended mode. And there is no close. So users don't close apps. So of course, this model has a problem. The memory is limited, and we can't keep 100 apps open forever. So at one point, the OS will need more memory for the current active app, and it will actually kill some of the background apps. That process has different names. It depends on the OS, but it's actually pretty similar on Android and iOS. On Android, it's a little bit more complex because we don't have just the concept of the app. We also have the concept of an activity, but we are not going to get so deep on that today. But anyway, if the OS is actually killing your app, or destroying your app, or disposing your app still appears as there. So it's not removing the app from the list. You still see the screenshot. Because on mobile operating system task managers, what you see is actually some kind of navigation history. It's not really a task manager, like in the OS Alt-Tab. It's not the same. So having that in mind, now going back to web apps and JavaScript, we can be on any of these situations. So our content can be actually in memory and running. Our content can be actually in memory and not running. That's the paused state on that diagram. Or our content cannot be in memory at all. But for the user, it's still there. We see the screenshot. So the user thinks that the content is still there, but it's not. Here, I have already a background audio playing. So if we look at the HTML, in the HTML, I have a video element and an audio element. This is HTML. Okay, nothing really fancy. But using JavaScript and these APIs, I can actually add all the metadata. So that's the change. For example, when I'm playing here, this is an open source royalty-free song. So when I'm playing, so in the button play, I want to add the metadata. So that metadata will let me, using the media session API, will let me in the background interact with the OS. Okay. So from here, for example, in my btn play, before or after the play, it doesn't matter, in the event handler, so I'm going to talk with the navigator.media_session.metadata object. And I'm going to create a new media metadata. There is a constructor for that receives an object with all the properties that I have to set. There are 3 mandatory properties: title, artist, and artwork. You need to provide those 3 at least. There are more properties that might be used or not, or might be ignored. So for example, in this case, the title is Too Much Funk. That's the name of the song. Then we have the artist. This is the real artist, T-Bogues. The album, we could say, well, I don't need the quotes here, that this is Frontend Masters Greatest Hits, maybe. And for the artwork, it's actually an array of images that is following the same format as in the web app manifest for PWAs. I'm not sure if you have that object in mind, but actually it has source with the URL of the image, type, and sizes. Oops. So that's the structure. Okay. So I do have an image. It's media thumb.png. Okay. So I'm going to use that one. So it's media thumb png. The type is image png. And the size is, if I remember correctly, it's 800 by 800. So you can provide many, and each OS will pick the one that it prefers. Okay, so there are no standard icon sizes here, so every OS will just take wherever you provide. So again, this is just metadata, and over the same object, I could also listen for JavaScript actions. So then, while you are in the background, from the watch, you can do something in JavaScript. Make sense? You have a question face. I'm not sure.
I'm just thinking about like the other ways that you can interact with that. So then, like, I think also like Siri and other voice assistants can then interact with that media session.
Yeah, that's correct. So both assistants,
Yeah.
They are connected to those as well.
That's very interesting that you can, like, if you're like streaming it to one of those speakers, you could then interact with your voice to have it navigate through part of your JavaScript.
Yeah.
I'm just thinking of the weird things you could probably do that with that. Like, if you go backwards, it actually like moves down the page. Or
Also,
the page.
yeah. Also, let me increase the weirdness there. You could stream that if it's video, if it's audio, also you can stream that to a Google Cast device or Apple TV, and also you can use your remote control. So from your remote control, you could be actually executing JavaScript.
And the HomePods can hook up to an Apple TV. Mm-hmm. So if you use the Siri on the HomePod, it's going to go to your Apple TV, which goes to your phone, which controls a website.
Yeah.
Which is very, very strange.
It actually could be someone on a television program that you're watching that says the activation word for your HomePod. Remote execution attack.
Exactly. So now you have a remote voice JavaScript injection attacks.
But you could like use the seek function to like scroll through your page and do like percentage of the way through your song is how much of your website you're scrolled down to, and have the worst website possible.
That's what I want.
Well, let's see this in action. Let's see if that works. So I did that on the audio plane is this one. So if I hit play, we have the song, and on the OS, you can see here, Too Much Funk, okay, with the Frontend Master logo. So that works. And if we run this on the phone, I can show you that later if you want, it works also on the watch, just by sending metadata. And that also works even if I minimize this, so I'm not actually seeing that, I can still play that. And remember, that play is not just playing the audio element, it's executing a JavaScript event handler. And you can do wherever you want there, not just working with the audio that you're hearing. Let's go back then to our service worker. I think that at the top we already have an event listener. So what we need to do is talk to our registration, and from here we're going to show a notification. So if you remember, we have already seen before the other API. The other API was actually pretty similar, but we were creating a new notification. It's actually pretty simple and pretty similar. It has the title, like Frontend Masters, and then options. So actually, this is the same or a similar signature, but a different way to access that notification factory. Okay? So here it's show notification, and the other one was new notification. Okay? So mandatory body. Again, we can take the data as text or as JSON and then parse the data that we are receiving. It's up to you. Or as text, or no. Or you can just do here any text. Can be fixed, can be wherever you want. You can go and check and create a message from IndexedDB. So body is it's mandatory, and also icon. So for the icon, I will use, I have here in the public folder, images icon PNG. And kind of that's all. How can we test this? Before checking if the server is sending the message, how can we test this? We can use the tester in Google Chrome. Okay, so that's the simplest way to test this. So we can go back here, go to the application tab. Within service workers, we have a section for push. If I send in a message, push, I didn't get it because we need to make sure that we have a new version of the service worker. Remember that? Check update and reload, because we are changing the service worker. Okay, how do you know which version of the service worker is currently running? Because the file is this one, but you don't know exactly which version do you have. You can find them in sources under this little icon, that's service worker, and here you can see the current version. So you can see that it should show a notification, right? So from here, or from the server. Okay, so what about the server? Again, we are not covering the backend part here, but what I did is that broadcast.js file. This broadcast.js file is using that web push library. Okay, it's using the private key and public key, and it's creating the message. Okay, and actually this is the code. It's not really complicated. Okay, but it's right now it's taking our database, and for each user it's creating a new message. You need to create one HTTP request per user, per endpoint. Okay, and for each one you're going to use your keys. Why? Because also you use that to encrypt that message. So you encrypt the payload with users public key and your private key. So okay, so it's a complex scenario to avoid security issues. So to use this, you can open a terminal, and from the terminal, using Node.js, you use node space, okay, broadcast. If you just use the tool as this, it will create a message. This is a test push message from the server. But if not, you can add a message after that. Like, I don't know, hello, Frontend masters. Okay, so this is going to loop through all the browsers, and it's going to send the message. The problem that I do have right now, so if I look here, I do have some messages, okay? So I have one, by the way, for some reason, well, not a reason, because it's Safari, Safari is not using the icon for now. So you can see only the name of the website, the domain, the origin, and hello Frontend Master. So Chrome is using the icon, okay?